I want to explain to everybody why I'm so interested in telemetry. I was born in 1953, so in 1961 when John Glenn flew, I was about 8 years old. Not quite old enough to really understand what was going on, but old enough to be interested in what was happening on the TV. By 1963, I was 10, and of course, was completely understanding of everything else that was going on in the space field in the 60s, which was crazy exciting to me. So when I got older, went into the Navy, and got into the electronics field, all that telemetry data that was used in the space program to figure out why something went wrong based on data that was transmitted during a launch was just really interesting to me. The fact that you could have a massive explosion of a rocket and still, after the fact, figure out why it happened. And you were able to fix the problem for future launches was just like, man, that's magic. That's just really science to me. Couple that with the fact that I guess electronics technicians are supposed to figure out how you transmit and receive that telemetry, what telemetry values are important. That's kind of the electronics industry that figures that out, and it may be other industries that massage the data to figure out based on this at this moment, this happened, the other. In Crossfire Mavlink, if you look at the Crossfire transmitter manual, you'll see here these are the available sensors with OpenTX. This first part, the first 10 sensors, have to do with the RC receiver. That's where they come from. RSSI, another RSSI, link quality, signal to noise ratio, all down through here, another link quality, antenna. These first 10 down to right here are all related to the RC transmitter and receiver. Have nothing to do with the flight controller, have nothing to do with Mavlink or anything. Within this area, I haven't yet used RSSI to see that my RC receiver may soon become disconnected. Multiple reasons. It's going to fail safe if you have it set up properly. It's going to fail safe if it loses link with your radio and come home. That's in a perfect world. That's not the major reason. The other thing is, seeing I had my ham license and could use the higher power and better frequencies legally, I went with a long range, easy UHF 433 megahertz system day one. Because one of the worst things I could think of is for my platforms to run off and do damage to people or property. I just didn't want to put a hiccup in other people's lives, even for an hour one day when I have to recover my stuff from their yard, that kind of thing. I just don't want to do it. Although I have landed on a used car lot and did $500 worth of damage. Anyway, so I had never used really any one of these first 10. Damn it. Come on. These first, I was trying to get it lined up right here on this line. It won't. Of course it won't when you want it to. So I've never actually used RSSI, link quality, signal to noise, any of these things in this top list from antenna up. The first 10 of 21 sensors that you get via CRSF, or just these first 10 I'm talking about that come from the RC transmitter and or receiver. Truthfully, they're not that important to me. The next group of 11 sensors, 11 sensors, has to do with some things that I am very interested in. Knowing the number of satellites before I fly is extremely important to me. I want 7 or more. Most people 6 or more. I'm always a little weird, but I do 7 or more. Altitude is good to know. I can pretty much see visual line of sight that my platform is above the ground or still on the ground if it's a rover. I guess I don't care about altitude if it's a rover. GPS coordinates I care about. If I want to go get it after it crashes or runs out of battery, that's where I go to get it. So these are battery voltage is important during the flight. Current draw isn't as important during the flight as it is for tuning the current draw at a certain throttle position. You may have to change props, motors, or whatever to get your platform to fly at a current draw that is reasonable, that gives you long battery life, doesn't generate a lot of heat in your system. But these become kind of less important to me. Current consumption, not really important. You see, these are coming from the flight controller. From GPS down can come from the flight controller, or they can come, some of these battery voltage, current draw, consumption can come from a crossfire receiver, Core Pro, that kind of thing for these 3 right here. Down at the bottom, flight mode, yeah, that's pretty important to me. I like to hear that when I'm changing modes, so I get a verbal confirmation that I'm in the mode I want to be. I can do that on OpenTX just based on a switch. I don't really have to have telemetry for flight mode. But prior to me getting the Radio Master 6 months ago or so, I didn't have that kind of functionality on my radio. I had to rely on my ground station for that. Pitch, roll, and yaw aren't as important to me during flight as they are in the event of a problem. So these are the 21 sensors that you get when you have OpenTX CRSF. Like I say, the first 10, not too very important to me. The next 11, there's at least 5 out of them that not really that important to me. So these sensors are not really what I'm talking about. This is also the information that you will get back in Yahoo telemetry. I have Yahoo telemetry and iNav telemetry working on my Radio Master radio. I don't think they're being saved anywhere in the radio, but they can be received and viewed on my radio screen as I fly, if I can see the screen in the sun, which I still haven't tested in full sunlight. So really, for me, I'm only getting back GPS, altitude, sats. Maybe we'll throw mode in there just for kicks and grins. 4 sensor points that even matter to me with the CRSF. That's why I want to get the MavLink going. These are great to have, but they're just not the detail that I want. If we look at Mission Planner, we'll go over here. Anytime we connect with Mission Planner, we're connecting MavLink. And this MavLink data is what I want to be able to do. So via Crossfire down to this ground station, I can just click like this and it will be doing everything that I'm currently doing with a USB cable or telemetry radios on platforms. Now my telemetry radios, I've had problems with them on and off for 8 or 9 years. I'm currently having a problem with them. I would love to toss them for much more than weight. They're so light now compared to what they were 9 or 10 years ago. The weight isn't as important as the functionality. If we look right in here, where are we at? Status. These are the telemetry points. You can see some of them moving around right now. Some of them not. I don't look at any battery except the first one, and you can look at like 9 batteries or something like that with this. But these are the telemetry points that are constantly being sent back to the ground station and saved. There are hundreds of them. They're not always used. Again, there's probably, I think I counted 10 possible range finders that can be put on and looked at. Here's your RC channels, what their current PWM value is for 16 of them. Climb rate. I don't get climb rate out of CRSF telemetry. It just isn't there. Keep going on over. You can just see we're in the E's alphabetically at this point. There is just hundreds and hundreds and hundreds. These are sent back up to like 4 times per second and saved away. The ones I am most interested in is, one of the ones I'm most interested in is vibration in the IMUs. That may be these right here. For in flight, I want to see what it was in flight. Was my platform just vibrating around and causing problems on me because the props were out of balance? There's 8 of them. This is how I would get that information. The little old telemetry that CRSF sends and Yapu and iNav telemetry use to me are just, they're not laughable, but they're just not the kind I'm looking for. Also over in, where is that at? That's in setup, advanced. I think it's Mav Link Inspector. Yes, if we come into this, this is in real time. These are subcategories of sensors here that are being sent back right now. This is the data rate that it's being received right now out on the end of it. If we start opening these up, you'll see there's the actual sensors underneath these subcategories. And again, if you were looking at more than one battery, there would be more than one battery in this status area. This is constant and real time. It's just sitting on the bench right now. So a lot of these are doing nothing at this moment except being saved. Well, they're not actually being saved, I don't think, until you start a flight. But you can see there's just a plethora of them. These are the ones I really love, is the raw inertial management unit values, the gyros and accelerometers and what they're doing at the current moment. Here's your RC channels, 18 of them, what they were at any moment. If we look at one of these that might have some data in it right now, you can come in on one of these, even during the flight, and say, graph that and show me what it's been historically for this flight, and it'll just take off and start giving you a graph on the screen. You can also do this after the fact with like vibration and go, ooh, look at that. Well, and you can overlay onto it your pitch or something. It's where you can see that, man, when this platform pitches more than 45 degrees, it just starts vibrating like a bandit for some reason. The CRS telemetry gives you nothing like these values. Here's your scaled inertial management unit values, your pressure sensor values. Let's see if the absolute pressure in this room has been varying while I've been sitting here talking. Sure, it has been going up and down. That's probably more sensor drift at this point than anything, because if you track how much it's changing by, it's probably a very minute amount. But I'm just going to run back down through this list. Here's your accelerometers and gyros and magnetic offsets. Just those aren't going to change. Those are magnetic offsets are kind of fixed. They can change based on GPS. If you cross certain lines on the Earth, that would be a really long flight, where the offsets change dynamically. But you can see here, look at all these things. Ground speed. Here's some of the things you normally get from CRSF, your airspeed, altitude, climb, ground speed, heading, throttle. Here's the vibration I was talking about. Vibration on X, Y, and Z on the system. Let me shake the platform around. See, when I shake the platform around, these values just change. Let's look at vibration in Y and graph it. Let's only look back 10 points. And that's probably too tall to make anything out of it. That's me shaking the gyros around. Wind speed calculations based on your wind speed indicator. So look at all of these telemetry values that can be saved away in your ground station. I liken this to insurance or computer backups. Something you spend time and money on, you hope the time and money is useless. If you don't have a computer crash, you don't need those backups. Every one you made was just wasted time and money. If you got car insurance and you don't have a wreck, it's just useless money. If you have a wreck, now we're getting where now that insurance becomes valuable. You don't have to pay out of pocket. Same way with telemetry. Every time you get your platform back, your telemetry data is just useful. Well, I guess for me, my telemetry data is majorly useful when I come back because I like looking at stuff like the vibration and stuff during the flight and seeing if I can reduce some of them problem areas. It's just a tool. Right now, because I have never gotten MAVLink data going over Crossfire, I don't know if I get all of these. I suspect I get all these values constantly via MAVLink over Crossfire. I don't think it would be any different than the way I'm connected MAVLink right now with a USB cable. But this data is most useful when your platform does not return to you. GPS coordinates are extremely useful. You can go into your telemetry, look at your last reported GPS position when you crash. That is likely where your platform is right now. You can put that in your cell phone like you're doing a geocache mission and go straight to your platform with that. So capturing that would be very valuable. Historically, we've shown GPS coordinates in the OSD for that same reason. If you record it on a DVR on the ground, you can rewind the video after you crash, look at the coordinates on the screen just as it augers into the ground, and that's where it's located. I think everybody understands the telemetry can be very valuable. But to me, as an electronics technician, it's just like the bread and butter of my profession. I want to see it all. I want to play with it all. I am more interested in the minutia of telemetry than any non-electronics engineer will ever be. So I do have sort of an abnormal love for telemetry, but I don't think it's abnormal for my 50-year profession. I don't think it's abnormal for my love of electronics, but I don't really want to force that on other people. But I do want to get Mavlink going over CRSF and see if I have all of this data, uh, because like I said, I'm having trouble. I've always had trouble connecting telemetry radios. I think my biggest problem is with the telemetry radios is I always have them too close together when I try to connect. But I'm still working on that one because I do have telemetry problems right now I'm trying to solve. Telemetry over CRSF, if it gives me everything that this telemetry connection does right now, and I think it will because Mavlink is Mavlink. Mavlink is a telemetry protocol. Mavlink it's just made to do telemetry. So if I seem obsessed with telemetry, that's why. I really do like telemetry. And again, if your platform comes home, even if it's just saving the telemetry to the SD card, you can take the SD card out or read it with a USB cable on some platforms. It differs from platform to platform, hardware to hardware, and you can see vibration after the fact. But that's only if you get the SD card back in your hand. Even if you get your platform back, but your SD popped out for some reason, not a likely scenario, but you still wouldn't have the data even though you've got your platform 100% back. That's why I want it transmitted and saved on the ground station dynamically real-time in flight. I think that's all I really need to say to explain myself. So again, that is why I'm so crazed about telemetry. Thank you guys so much for your time. I've really been humbled by some offers of help lately. For 50 years in computers and electronics, I've always been the guy everybody was asking the question to, and companies hired me to answer their questions for their customer, paid me for it, so they wanted great answers. uh, so it's humbling when I have a need for help and others actually reach out and give me that help. I can't say how much that pleases me. I can't say how much I'm thankful for it. So I'll just end this with a simple thank you so very, very much.